we're right on time right now. Thanks for coming to the session. Yeah. It is my deep pleasure to be part of a really interesting interdisciplinary field that just recently finished a project that was an NSF-funded, really outreach and science communication project. So we've got a kind of a panel of folks, and we're basically all going to try to talk less and demo more. So our big plan is that we're going to kind of go through some of the phases of what was this project about, what were we trying to achieve, and at the end, like, how did it perform, some lessons learned along the way. And then we're going to walk across the street. We're actually going to leave this room. We're going to walk right across the street, and then we'll show you the final installed version of it, and we'll do Q&A kind of while people are playing with it, which should be a fun way to do it. So we'll keep our time in this room is kind of moving quickly, and then we'll get over next door and start playing with it, and we can do talk over there. So without further ado, this is kind of you take it away, Jim.
All right. So I'm Jim Madsen. How many people have heard of the IceCube project? Okay. So this is the deal. I'm the IceCube education and outreach person. So next time, everyone has to raise their hand. They always say, hey, how come everyone doesn't know? So IceCube is a large international project located at the South Pole. And what we've done is build a very strange type of telescope into the ice. Okay, so this picture was taken down at the South Pole just a few days ago. The last plane left about mid-February. The next plane won't come back until the end of October. And so we have two people that we call winter rovers that are keeping our experiment running. There's about 40-some people there during that time. Then the planes will start flying again. There'll be about 150 people there during the summer. So my job is just to tell you very quickly what this project is. As I mentioned, it's a large international project. There's about 49 institutions involved now, about 350 scientists. The project is headquartered out of UW-Madsen, funded by the National Science Foundation. So the first thing you have to do is convince you this strange thing we built is actually a telescope. And I'm not an astronomer, so if you ask me what is a telescope, it's, you know, the picture I have in my head is kind of just like this picture here. I picture an optical telescope, but here's the deal on astronomy, right? Everything we want to study in astronomy is too far away to go directly to, other than the sun. You may have heard that there's a probe that was just launched today that's going to go circle around the sun. And the things that are happening are too extreme to reproduce in the laboratory. So the way we learn is something out there has to be giving off something we can measure. And the way we make progress is by looking in new ways. And so what we've done is developed an entirely new way to look at the universe. That's important because when you look in new ways, you see new things. So this is the easy part of the talk. Everyone recognize this? Okay, that's your hand, right? How about the object up above? Anyone know what that one is? So you're like me, you're not an astronomer. So that's the Crab Nebula. It's a leftover remnant from a star that exploded about 500 some years ago. Okay? And that's what it really looks like, just like that's what your hand really looks like if you take a picture with a camera. But it turns out this is also your hand, right? It's just that we've taken an X-ray rather than an optical. And believe it or not, this is the same object as that. Right? That's what it looks like if instead of seeing with visible light, you would see X-rays. That's what that same object would look like. So we learn new things, just like by looking at our hand, we see that internal structure. We see new things with new rays. So the universe is huge and mostly unexplored. And if we want to find new information, we have to have different ways to look. So we have some crazy big thing way distant that we're interested in exploring. It's got to give off messengers, and they have to be able to reach us, and then we have to be able to detect them somehow. The first people that did astronomy used their eyes. We are going to use a particle that's almost invisible, okay, called a neutrino. All you need to know is that it's not quite invisible. Okay? And if you're clever enough, you can build a detector that enables you to see these things and learn about this object out in space. And what we're in particular going to do is what's called multi-messenger astronomy. So when we find a neutrino, we're going to go, whoa, there is something big and powerful out there. Go look with your telescopes, because space is so big, the telescopes that can see far can only see a narrow distance, a narrow width, right? So it's hopeless if they just look at random. So what we're going to do is be the searchlight to say, here's where they are. So in order to do that, we had to build the biggest science project ever made. So this is the scale of the Eiffel Tower, okay? What we did is we melted holes in the ice over 1.5 miles deep, 2,450 meters, and then we put light sensors in, like this, 60 of them in each hole. Okay? For 1,000 meters, the bottom 1,000 meters, we made 86 holes like that. It took us 7 seasons of working because we could only work about 3 months out of the year. All the other 5,000 were those light sensors. And what we're going to do is look for particles from outer space. So these pictures are not the best resolution, but that's what this spot we're at looks like from outer space. So there's Camp Randall Stadium. Here's where we are, right here, right? So this is how big our detector would look. It would basically cover that whole map that I just showed you. And what happens when we see a neutrino interaction is the detector sees some light, and then we can trace the path that it went through the ice like that. And so then we could say where it came from. So for over 100 years, we've known that there are very high energy particles coming from outer space. This September, one of these very energetic cosmic engines produced a neutrino that we are able then to trace back and send out an alert. And other telescopes swung around, and so for the first time ever, we identified where those particles are being produced, at least one site. So that was on the cover of Science magazine just a couple weeks ago. We had a national press conference out in the National Science Foundation in Alexandria, Virginia. And then, just fortuitously, we had a game that would explain all this.
Attempt to explain.
So this is artist's inception, right? And what it's supposed to show is these are the neutrinos coming from outer space, and then these are the light that comes from that same object. And if we can first find them with the neutrino, then we can tell the telescopes to swing around, look in that direction, and they can identify it. So that's what we do. All right?
So I'll talk a little bit about kind of how this project came about. So one of the things you may have noticed is that these data sets are inherently very 3D. As Jim said, we're trying to find an angle in space. And so a few years back, we had a virtual reality environment called a cave. And we developed a way to visualize these data sets in 3D. And so people could stand in this room and they could see where these events are coming from and create this visualization. And then we also had an event where we brought people in from the public. We had people from IceCube. They could go into this environment. They would talk about their experiences in Antarctica. And it was a pretty powerful event for all the people that came to this. And using this as leverage, we found that NSF had a call that they basically said, you know, we're investing lots and lots of money in Antarctica, and the general public doesn't know that much about it. And so can we develop new ways to try to teach people about all these cool things that are going on there? And so our team thought, well, you know, we've done some stuff in VR, consumer VR is coming out. Maybe we could utilize those technologies and try to reach a broader audience. And as we were brainstorming, we also realized that, you know, we've done work on communicating with people before using touch tables and different types of table devices. So we had this idea of, could we just combine the two? So here's our hilarious mock-up I found in our grant application of some people of the touch table and some people with VR And the idea is that we're going to put it in this building that you're going to go to across the street, and it's going to be this exhibit that's open to the public. And one of the things we realized as we did that is that having something open to the public means that you have to kind of rethink the way you do things. And so here are a few different goals we realized that we had to accomplish to make this project be successful. So the first one is, when we had done these events before, we had someone there who was more or less a tour guide. We had someone there who could guide someone through the experience and talk them through what they were seeing, what they were doing, how to interact with the system. And if we're going to have something that's just sitting open to the public, you can't do that. You can't assume that. You need to make something that someone who just walks up there by themselves without any kind of tutorial can just use. The second goal of ours was that this needs to be a really quick experience. If this is going to just engage people who are walking by, who people in the building, this can't be anything that's very long. So you need to have something that really can engage them, but engage them very quickly. So something in the order of a few minutes. The other thing is, it has to be fun and entertaining. If we were to develop something that's kind of boring and bland, we kind of felt like no one's going to use it, and no one's going to get excited about this, and we're going to not be really hitting the goals of our project. And then finally, you would really hope that at the end of the day, after somebody's experienced this short session, that they've actually learned something. So these are all of our goals for this project that kind of get condensed down. So we did lots and lots of brainstorming. These are some pictures of our whiteboards that we came up with lots of different ideas of how in the world do we accomplish all these goals simultaneously. We did a lot of different iterations of this project. So here's kind of one version of different ideas that we were kicking around in terms of how these interactions may work. And all of these then we would go back and revise and edit. But if you think back to that kind of hilarious mock-up I had, the final exhibit actually kind of looks similar, and you go across the street and see it. So again, we have a table display with some VR machines all hooked up to it. So this had lots of challenges, and I'm going to now hand this over to David, who's going to talk about the challenges for VR.
Cool. So our role in the project at Field Day was to kind of concentrate on the VR part and think about game design and how we would do a game around this. So let me mix challenge with excitement and lessons learned. So one of the things right out of the gate that was really interesting is that this is really not easy science. I mean, the whole premise of this is pretty abstract. You know, we're going to have a telescope that looks in every direction at once, that has like little things that light up, and they're going to tell us where the universe came from. This isn't like, you know, people that eat chocolate are happier kind of science, right? So that was a problem right out of the gate. Another problem that we had is when, like, we're putting things on screens, so there are visuals involved. And when we would talk with the experts here, and we'd say, okay, so what does a blazar look like? The general consensus was, that's a stupid question. But we have to put something on a screen. So what does it look like? Like, I just got done watching a cool movie and they put something on a screen. Like, how can we do that? Like, what, you know, like, where do we go from here? So that was really challenging. So I would say a couple big, and then also VR technology itself is kind of semi-unexplored in museum spaces. There's a lot for us to learn. So a couple breakthroughs, and now these are just successful, fun stories to tell. The first one is there was a moment that happened when our art director was talking with Silvia, who's James's kind of counterpart, and the question shifted not from, in this case, what does a black hole look like? Because that was the question that's a stupid question. And it turned into, what would it feel like emotionally to be looking at a black hole if you were out in space and it was taking a virtual view? That question, it was like everything unlocked, actually, at that moment. Because it went from, is the math right, are we being true to the science and having the rigor of science, to realizing that these are human endeavors and they're full of human experiences. So kind of probing on that, you find out that the people that go to IceCube are badass. Like the people that actually take the boat to the, to the flight, to the, the crawler thing that goes across the ice. These people are like hardcore explorer types. These are not lab coat scientists. To use kind of the language of them, they're explorers. They're pioneers. They're like searching deeper in space than anyone has ever gone before. Right? So as soon as you start unlocking this kind of language, we're like, oh, okay, we can build something like that. So what happened and what you'll see is that we created a 5-minute narrative. It's a story where you take on the role of being an explorer. And the real purpose of it wasn't some sort of
kind of impartation of knowledge, but it was an impartation of human drive and desire. A little bit of mystery, a little bit of fear. It was, let's turn you into an explorer and have you experience what it's like to be a little explorer in the couple minutes that you're going to do this. So breakthrough number 1. When working with subject experts that are highly mathematical, ask them about their feelings. Part 2 that was really interesting is that VR is primarily about immersive sensory experiences, not mechanics. And for our team, we're kind of a mechanics kind of shop. Like, we do a lot of science games. It's a lot of, there's a widget in the middle called whatever, science principle, and there's some inputs and some outputs, and you're going to wiggle the thing to find out how it's going to simulate, and it's mechanics-heavy stuff that we make. So this was a total shift. This was all about the script. This was about, we're going to put you in these really immersive situations. The mechanic is going to be really thin. In this case, we have 2 mechanics. One of them is you get to switch which spectrum you're looking at the world with, and the other mechanic is you can pick the ray where we think the neutrino came from, and you can warp out using, we call it the impossible drive. So you can travel, and you can flip spectrum, and that's it, and then a story unfolds. So this was another big shift, a narrative construction of a scientific system. And then the last thing I'll mention is just VR itself was kind of weird. A lot of people still haven't used VR. So one of the things that we found very problematic is that a kid would put on the headset and then kind of go like this, and there would be like sound coming from somewhere, but they'd just be looking out at like the vastness of ice at the South Pole. And during playtest with hundreds of kids, we have a science festival, it makes it really easy to test this stuff. It was always like, I'm not a creepy guy, but I need to have your kid and like turn them so that they can see that there's more to explore. So we had to build some systems and really to just kind of onboard people. VR is not natural yet, so we really had to just onboard people into this experience. So I would say those 3 lessons were kind of some key things we got as a designer that really unlocked a whole other way of looking at how to build an experience like this. The main takeaway is it is very experience-centric and not very fact-driven. I'll leave it there. That should turn on again.
All right. Hey everybody, I'm Ross Trednnick, and I work over with Gagnon, and it's really awesome to be a part of this whole project. We actually kind of flipped roles in this project. Kevin and I and other folks over there do a lot of VR stuff. David and these guys have done a lot more games for learning stuff, but it was actually, we kind of flipped that, which was pretty cool to do actually this time around. I have a games background, so it was nice to jump back into some of that. But we did the primary work on the tabletop part of the exhibit. So again, a lot of challenges came up with this project, as Kevin alluded to, and I'll just go through three of them briefly that we found on the tabletop, especially. Starting out with kind of just how do you get someone to know what they're going to do when they just walk up to this, have no background at all with neutrinos, IceCube. As we alluded to, it's pretty complex science, complex stuff going on here. So, we got this ideal scenario typically. In the way I think about it, at least for games and learning, is that you can have this game that exists and someone can just come up to it and play through it a few times and then gradually just kind of understand what they need to do. So it's kind of like the golden ticket of Willy Wonka's factory. But does that always happen in practice? Well, not necessarily. And also alluding to that a little bit more is that as they can play through it more and more, then they can naturally just learn some of the content. And while this happens with certain games, I'm sure very well, we found that it gets tricky because when you have this content subject matter that's so sort of complex, and someone is walking up to it with no background, you can't necessarily assume that they're going to be able to do this without some sort of additional cues that we found we had to add as we were going through the iterative process of the design of this game. So kind of some solutions there is really kind of hammered home what you need to do just through some interactive means on the tabletop. So we have a tutorial that continuously runs when no one's there. So this also gets into some of the issues later on that I can jump into about it being a museum experience, and it needs to be constantly running. So we have a tutorial that goes through and gives a little bit of background information and then just some basic kind of hints as to what you should be doing in the game itself. And then we also, there's also the situation where people come up to it and they don't watch the tutorial. You can't assume they're going to even watch the tutorial, so they'll just come up and hammer on it and start going to town. Which at that point, then they still might not exactly be understanding what they need to do. So we gave this other option to say, okay, we're going to look at some specific instructions now. Just come up to it. And then furthermore, we even added a technique that just is like makes you go through sort of the exercise ones, which is just a pretty basic swiping mechanic that most people are obviously familiar with these days due to mobile phones. So getting into just what the tabletop itself kind of looks like in general. So as you can see, this is a screenshot of the layout, and it's a multi-touch table. It's a 4K resolution, about 65 inches. So it's a large play kind of touch space. You can see down on the lower half of the screen is an example neutrino event that Jim showed in that video earlier. So the idea is people come up to the table once they get going into the game. They swipe through this. The array here in a direction they think that a neutrino has passed through that array to try to discover and understand the direction that the neutrinos pass through, which is the scientific end of things, what they do a lot at the array, at the array itself and at the lab. But the problem with this is that this is we're trying to figure out a 3D direction, but we got a 2D display going on here, so it can get a little bit confusing, especially early on. We didn't have the camera view sat stationary, for example, and it got difficult to tell which detection unit DOM is there called exists in front or behind, and kind of what am I looking at? So we added some additional features that kind of help that out a little bit. We felt, which gets into some basic depth perception type stuff, added some fog to the scene, rotated the camera around, which I felt like really helped and added to things, and that also added a bit more of a gameplay mechanic to it too, so you could swipe from different directions and pick up on things. So then furthermore, we added kind of these top, front, and side views, borrowing from sort of typical 3D design architecture type programs, which lets you then try to figure out these directions from multiple angles, multiple viewpoints, which also I believe is a technique that some of the IceCube folks do, and also something they've done for other outreach events in general, where they have members of the public try to find these directions from different viewpoints. And finally, I'll just kind of finish up with some quick thoughts on just developing a museum-style experience in this regard. There's definitely extra challenges with it, but if someone just walks away from it at any point in time, it needs to reset itself back to a starting point that someone else can come up to, which in some styles of 3D applications and games, you don't need to worry about that quite as much. This is also multi-touch, so more than one person can play it at once, which added some additional things. For example, a lot of times we found that when someone finished, we'd show our summary panel that shows some information. Well, then their kid would be sitting there and hammer on something and make the panel disappear and invert things. So they had to keep in mind that adding a lot of timeouts to things so that stuff could stay up and present longer, things like that. So with that, I'll kind of turn things over to Rebecca.
So I'm Rebecca Kors. I came on last fall to help the team look at how effective this display or this exhibit is over at the Discovery Center. So, we studied the focus, of the project by looking not only at visitor outcomes. It's a really common focus that people zoom in on right away when they're studying an exhibit or an education project. And we also wanted to look not only at what was interesting, what's happening with visitors, but what was important to people on the team, even IceCube scientists, and also what was practical as far as how could we actually collect meaningful data over at the Discovery Center where we'll be. And what came out of that was a guiding question for looking at the exhibit. Can this exhibit gameplay actually promote public understanding or set awareness of a complex, high-tech science endeavor like IceCube? I think what David was saying can't be emphasized enough. This is a really complex idea, and we're trying to convey it in a matter, of a minute and a half. So. The study focused, this question, we looked at it with 4 hypotheses. Those were our central places that we focused. First, we thought that people who use the exhibit would gain a basic understanding of IceCube. And then we thought that there would be a difference between this gain in basic understanding between people who use the virtual reality and the people who use the tabletop component of the exhibit. And then, yeah, we thought that the virtual reality would spark more curiosity about IceCube than the touch screen. And finally, we thought that people who performed better at the games would have a better understanding when they were done playing the game. So we also had an evaluation question. We wanted to know, as we were conducting the study, are these games functioning for people? Right? Really looking at the quality of the game experience. So let's get the question again. Oops, I'm going to go just right to our sampling plan to collect data to answer, to explore these hypotheses. We started in January. I conducted interviews with 10 people who played these games, 5 female young adults, and then between the end of March and the middle of July, we had surveys out. These are electronic surveys. So one was embedded in that touch screen. So when you finished the game, a pop-up window came up, and you could activate the survey. It was about a minute long. And with the virtual reality, if you were playing a virtual reality game, then when you took your headset off, you could answer a survey, complete a survey that was on an iPad on a pedestal. And we actually got 160 people who completed that survey. That was pretty exciting. And 60% of those were female. Again, they were young adults. And during this data collection, we had a special day where we really wanted to isolate their game experience, right? And look at a pre-post situation. So I and another person from our team, we were at the exhibit with iPads. We would hand someone an iPad, have them take the first part of a survey, and then they play the game, and then we take the second part of the survey. Good. So I want to move on to the findings. So the first thing we found is that people like the experience, right? Especially with the VR, they felt like they were in space. They gained some new understandings and got some specific suggestions for the game improvement. And we found out a lot of people wanted to learn more about the project when I talked to them. And we used these data to improve the exhibit, and Ross talked about some of those already. And finally, I want to talk about the first survey findings that I'm analyzing here. Just started looking at perceived understanding. We asked people to rate their understanding of the IceCube project on a scale of 1 to 6, 6 being expert. And before the exhibit, they rated it 1.6, and after 3.3. And that was this 160 group of people that just took the survey after the game. If you look at the pre-post, we actually have a confirmation of that, or triangulation, with similar data there. Before was 2.1 and after 3.7. Now you can also see that we had 2 multiple choice questions. Where is IceCube? With people answering 83% correct, and then the pre-post in a similar range. And then where do neutrinos come from? 77% correct. And then with the pre-post showing an increase in their understanding of that question. More got it right after they played the game. And with the concept map, we had actually a box. We were able to move concepts that had to do with IceCube into the box. And 51% got that correct for IceCube. The box was representing IceCube. And with the pre-post, we saw a slight increase from before and after. And then there's a concept map for neutrinos. And that was, people actually, moved more. I'm sorry, there's 73% of people who got that correct. That was a score of 4 or 5 on the concept map. And with the smaller group, the pre-post group, we saw an improvement in the score. So I just can summarize here by, there we go. Our data is showing that people gain a basic understanding of IceCube through the exhibit gameplay, and that it's sparking people's curiosity. And then for the rest of the analysis this month, I'll be looking at how the data compare virtual reality on the tabletop for basic understanding, curiosity in particular, and I'll look at the relation between performance on the games and their understanding of IceCube. And we can talk about more when we're over the...
Yeah, so let's pivot. We just talked about an experience, which is crazy, but whatever, we're at a conference, it's just how it works. So we can do Q&A while we're walking. So let's walk right next door. It's literally across the street. And we'll go play with it. We can do Q&A while people are playing with it. There's 2 things. So I don't know if everybody will get through it in the next 15 minutes. I know they won't. But we'll be able to watch with the person in VRCs, and we can still talk about it and kind of experience it ourselves. So everybody follow Kevin.